Structured programming. Structured programming is a methodology that is part of a renewed emphasis on software engineering, which involves the systematic design and development of a software and the management of the software development process. Software engineering views the development of a program as a coordinated activity involving people, tools, and practices, uses of modern design and development and management methods in an integrated approach. Structured approach involves the use of methods such as top-down program design and a limited number of control structures in a program to create tightly structured modules of program code. The effect of top-down design and structured programming has been used to lower the overall cost of programming. The structured approach promises to reduce the cost of developing and maintaining computer programs by standardizing program development and structures used. This increases the simplicity and accuracy and at the same time minimizes programming and maintenance cost. A traditional, flexible and creative environment provided to the programmer often results in complex and difficult to read programs requiring much testing before they are error-free. These are become costly to develop and maintain. Structured programming, on the other hand, emphasizes group responsibility for program development. It also brings in a standardization of program design concepts and methods, which significantly reduces the program complexity. These results highlight the reasons for structured programming to continue to be a popular programming methodology. Organizations using structured programming have shown the following characteristics. Program productivity. Programmers write more program statements as per day with fewer errors. The cost and time of program development and maintenance are reduced. Program simplicity. Programs are easier to read, write, correct, and maintain. Modular design. Structured programming is used as a set of tools to improve program organization, facilitate problem solving, and make code easier to write and analyze in both individual and group projects. Using structured programming, the solution to the problem is divided into segments called modules. A module is a logically separable part of a program. It is a unit, discrete and identifiable with respect to compilation and loading. In terms of common programming language constructs, a module can be a macro, a function, a procedure or subroutine, a process or a package. Each module involves processing of data that are logically related. Modules are functional parts that aid in processing. Ideally, each module works independent of other modules, although this is something impossible. Modules are ranked by hierarchy and organized on the basis of importance. The lower the module on the structure organization plan, more is the detail given to the programming steps involved. The controlling module resides at the top level. It gives the view of the overall structure for the entire program. The system is designed to give more detail at each module level. A module is coded and tested and then tested with other tested modules. This procedure makes program testing easier since there is only one entry point and one exit point per module. C language clipart. C is called a structured programming language because to solve a large problem, C programming language divides the individual small responsibilities to smaller modules called functions or procedures. One major drawback of C language is that smaller functions cannot be grouped inside a module or class. Also, functions cannot be associated to a type or structure, thus data and functions cannot be bound together. Structured programming constructs. The most common techniques used in structured programming to solve all problems are called constructs. Sequence, selection and repetition constructs are shown in picture here. These constructs are also called control structures. Using these three basic control structures, it is possible to write standardized programs which are easy to read and understand. Sequence structure. Sequence refers to an instruction or a series of instructions that perform a required calculation or allow input or output of data. Since these steps are executed one after the other, there is no change in the flow logic. The picture illustrates that program statements in function A will be executed before those for function B. In other words, we say that control flows from function A to function B. Selection structure. Selection refers to testing for a certain condition for data. There are only two possible answers to questions regarding data, -true, yes, or false, no. One selection technique variation is known as the if, then, else. The instructions that are to be executed when the condition is true follow the if-then alternative. The instruction followed by the else alternative represent what is to be executed when the condition is false. If the condition is true, the control will flow to function B and its statements will be executed. If it is false, function A is executed. Repetition structure. Repetition involves the use of a series of instructions that are repeated until a certain condition is met. Repetition involves the use of two variations, the for while and the do while. The while performs a function as long as a condition is true. On the other hand, do while allows a function to be executed until the given condition is false. Another marked difference is that the while first tests the given condition and then executes the function, whereas do while processes the function before checking the condition. Before writing a program to solve a particular problem, it is essential to have a thorough understanding of the problem and a carefully planned approach to solving the problem. Control structures. Normally, statements in a program are executed one after the other in the order in which they are written. This is called sequential execution. Various C statements we'll soon discuss enable the user to specify that the next statement to be executed may be other than the next one in sequence. This is called transfer of control.